Hi, everyone. Welcome to today's webinar. We have some exciting news coming from the TLS side, which stands for terrestrial laser scanning. My name is Nguyen. I'm the terrestrial business development manager for RIEGL USA and also the RIEGL California lead. Today, my colleague Thomas Gaisecker, who is the business mining division manager, he'll introduce himself later. And he'll present on the latest updates in our mining segment. But before we get started, if you can, I'm going to go ahead and post a couple of poll questions. If you can answer them, that'd be great. I'm going to go ahead and launch the first one. So the whole idea of this poll question is to see who's utilizing our the available network capability on the I-Series scanner. All right, so far, 27% say they have made use of the network, 60% say no, and then about 13% would like to. And then this next poll question is to see who is making use of the apps. Anybody's developed their own apps or making use of the apps. And this is going to be a part where Thomas talks about some of the apps that they have developed and have applied in a real-world settings. 29% people said yes, 35% people said no, and another 35% said they would like to. The apps are written in Python, and their apps are available directly on the scanner. Of course, we can share some too as well. If I have some, if you reach out to me, I can share some with you. Whatever I have. So yeah, without further ado, let's go ahead and get started. Again, my name is Nguyen. I'm the terrestrial business development manager for RIEGL California, and today my colleague Thomas Gaisecker is going to join us, and he's going to be presenting on what's the updates in the mining world for us. Today's topics are going to be TLS software, particularly RiScan Pro, multi-station adjustments, new features, and a new one-touch processing workflow, and also improvements in RiScan Pro. So there's been a lot of focus on our software and also apps, new development apps in our BZ I-Series scanners. And I'm going to also show you a special project that I've been working on for the last couple of months that's pretty neat, and talking about platforms and automated platforms, robotic integration, so very cool stuff. And then my colleague, Mining News, which is going to be presented by Thomas Gaisecker. So let's go ahead and move along. So some new updates in RiScan Pro, particularly MSA. So those that have not used MSA, there is an MSA2, which stands for multi-station adjustment, that allows you to optimization of all scan position within a 6-degree of freedom simultaneously. So the adjustments so that scan data from neighboring scan position matches. GNSS measurement also matches with the scan positions. And then measurements from tilt sensor matches with the scan position's orientation, right? So all this information during the adjustment, it's all considered. And I'm also using the external survey control values. But statistically correct optimization requires inputs of measurements accuracy correctly to MSA2. So what that means is that we can now input values, accuracy, horizontal and vertical accuracy to your control point, so that during the adjustments, we can emphasize the adjustments, the fine scan, the targets, where it ties directly down to the control points, so that you can get a better statistically matched to real-world survey control points. And that's all done in MSA2, which I'm going to go over the workflow. So you start out with just a blank canvas, and then of course the first step is to generate the tie points. Please always specify which tie point you're using, because a flat target has a completely different geometry versus a cylindrical target, and Well, flat target doesn't have an offset in the height, and cylindrical targets does, so it's very important to define your control points type. And then the next part is input your control, server control points. And this is the new part. So I'm going to take a minute to explain what's going on here. So you can see there's two new columns that's available to make use of control points and also checkpoints too as well. So you can see on the left column, you can see that you have some points that are checked and some are not. So the one that are, you can select them to be false or true, right? And the difference between that is that when you select it to be true, that means you're ignoring the scanner's absolute accuracy and precision, right? So that's the scanner, that's the scanner's accuracy and precision, the value of the scanner. So that it forces you, the software, to tie the control points, put a more higher emphasis on the control points versus emphasis on the scanner data. Now, you can also use different values for each control point too as well. So on the right-hand column, you can then specify the absolute accuracy of the X, Y value and also the Z values on your control points. And during the adjustment, it takes all that into consideration. So when you make it true, that means you want the algorithm to emphasize more on the use of survey control. And if you leave it false, then it will then emphasize more on the plane-to-plane scan adjustment. Now, you can have both. You can make use of the survey control and also the checkpoint too as well. So put the X, Y, and Z value accordingly to your survey control, so that the checkpoints is then separated from the control points. And plus, the checkpoints is not tied into the registration. It's only to then see how accurate is the data adjusted to the control after the MSA, and then the difference between the values is seen within the checkpoints. It's very intuitive. I've tried it a couple of times, and it seems to work very, very well. And this new tool can be implemented into, this new feature can be implemented into the new one-touch processing workflow, which we'll go over next. Very, very neat new processing wizard that we offer now in the latest version of RISCAN Pro. And then, of course, you just move on to find links. So down here, you can see I have it all selected as control points all the way towards the right, which is the point type. But you can just click on it, and then it becomes a control point as well. So if you click on it, it'll become a checkpoint. If you uncheck it, it becomes a control point, which is then used for the registration. And then the checkpoints are not used for the registration. And then, of course, you just move directly onto the step number 4, which inspects the data. This just gives you a layout of the overall standard deviation between all the scan positions, all the plane matching. Right now, I have it set at 300s, which is 0 is blue, and then anything over 300s is red. So before even doing the final adjustment, you can see a lot of the areas are around 300ths of a foot. And then, of course, the last step is just run the adjustments, which we're not going to go over. But again, the new feature in MSA2 is able to differentiate your checkpoint versus your control points, and also set the values to your control points, and then also making them true or false. True meaning that putting in more emphasis on the control points during the registration, and then false, it'll then do an adjustment using all 6 degrees of freedom during the adjustments. Okay, so for more information, please contact us directly. Contact me directly, particularly if you're here in the U.S., and then your respected support team for other areas around the world. We have one new exciting tool for our processing workflow. And this tool is really no different from what we have been doing is just combines everything to a one-touch processing wizard. And this tool has a lot of freedom, meaning that you can select to make videos or create a octave filter or colorize the data. So you have it has a lot of user-defined tasks that you can implement in here. So our scanner, the VZ I-Series scanner, particularly 400i, is known to be one of the fastest terrestrial scanners on the market. And this new tool is available only in version 2.11, by the way. So, and that version is available on our website. So please go down there, download it, and make sure you're up to date with your current maintenance of RiScan Pro. Why do we have to implement such a fast workflow for a fast scanner? Well, we want to be able to turn this data around within 48 hours, 24 hours of the first initial scan. So we can get a fast delivery of the projects to our clients, to our customers, or for internal use to make decision or to design from. And this tool, this new wizard, is really for all levels of users, whether you're a beginner or an advanced user where you make use of survey control and you're scanning up to 500 to 1,000 scan positions. Now you can check everything. Start the processing wizard and go take a break or move on to different tasks so that you can let this thing process in the background. It really takes the user interference out of it, which and then again takes a lot of errors out of it too as well. Let's go ahead and take a closer look at this one-touch processing wizard. That icon that has a number 1 with a arrow going all the way around, that's what the icon looks like, and it's right next to the automatic registration tool in the project manager tab. So again, this is brand new. You can only find this in version 2.11. So the filter task, right? So the filter task removes vegetation, deletes points, and particularly includes the two most important filters that I think most of us use in RiScan Pro, and that is the pole shape deviation filter, which eliminates the noise that are flying off of edges between two objects. This is because of the multiple returns capability on the I-Series scan or the VZ line scanners, and then also a reflectance filter that can remove dust particle in the mining setting or light rain and snow. So two most desirable filters that we all use, I think, and it's right here in the software. In the register scan task 3, you can also select to keep different type of return, right? So if you're in an urban setting, you may want to only keep the first and last echo, versus if you're in a forest where there's a lot of vegetation, you may want to keep all the echoes so that you can penetrate the vegetation and then achieve ground level so that you can remove the vegetation and then create a DTM later. So you still get a lot of flexibility with the data management during this registration and tasks and workflow. You can also check fine adjustment project. So I know I'm going to get some questions about making use of survey control. If you let me finish this slide, it'll show you on where you can make use of your survey control. Right now, you can see from task 1 to 12, you don't see anywhere for survey control, but we have to break the project for more advanced users. Calibrates the camera. So remember this part where you have to do a camera mounting adjustment so that it realigns the camera back to the scanner. Then it can colorize data from the images, photos. Generate an octree. This is cool. We can then automatically generate 3 different type of octree filters that it makes 4 different type of files. So you can create an octree filter, which is a 3D point normalization filtering tasks, so that you can set different desirable point spacing to each different option. And if you want to do just one, then uncheck 2, 3, and 4. If you want to do all 4, check out 4. So it gives you a little more freedom on the off-tree filter as well. And then export directly to LES 1.4. So after it's done, you can, the data would be exported into a LS format so that you can then use it in third-party software. And also creates a RiPANO too as well. Again, this is a very robust wizard, one-touch processing wizard that our colleagues have spent some great amount of time developing. Create 3D view, so, and then ortho plot. So this is a plot view from the top. This is great for roads and road profiling and road management, and also rural area, so that you can look directly from the top. And then the last one is video. I've ran this processing wizard a few times already. It's great. Really no failures. So far, I'll give you a little bit of time. I have ran this wizard on a project where I have approximately 50 scan position, and to have everything checked, every single option utilized, is taking about an hour and a half for about 50 scan position. Now that's just my test. Of course, the number's gonna expand when we add. The time's gonna expand if you add more scan position, right? The larger the project. So, and then the last part I want to go ahead and talk about in this wizard is to make use of the survey control. You have to break the task after step 3. So after step 3, you can, so for example, you want to check step 1, 2, and 3, and then when that's done, you open up MSA2, which I showed you a little bit ago, and then you just run through that 5-step workflow, and then go back into the one-touch processing wizard, and then continue to proceed on with tasks 4 through 12. Okay. Now I'm sure that as our development gets better with this wizard, I'm sure there's going to be a task in here to use make use of server control, and it'll probably just direct you directly to MSA2, which step 1 through 5. All right, so if you have more questions on this, please contact us directly. We're happy to talk to you more about it, but try it on your own. Start from scratch, start from the raw data, and then that's step number 1 is convert the scans if they haven't been already converted inside the scanner. So you really can't go wrong with this. Again, please set up Geosys Manager if you make use of coordinate system so that it doesn't fail or anything. All right, so new RiScan Pro version 3.2. There's really not much to show in RiPANO. Again, RiPANO is created directly from RiScan Pro. So in order to make use of the new version, you have to have the new version of RiScan Pro to make use of the new RiPANO version 3.2. It's a new rendering engine. What this RiPANO offers now is able to move around the project much more efficiently, much faster navigation between scan position, and introducing a new multi-resolution panorama, right? So we're just adding more different views to it, and then we're also making this engine, when we move around the point cloud, much quicker. And it's all hidden around the back, so the users don't have to do anything. All they have to do is just create the new version out of the latest version of RiScan Pro, and then you can, of course, make use of it. Again, there's no updates. Everything is the viewer's online, and then you can make use of the new version by simply creating the new in RiScan Pro 2.11. All right, so last topic for my part is a special project that I've been working on for the last couple of months. I know that my last webinar, I talked about different platform for stop and go scanning, and that's really just the motivation here, because along the line of tripod scanning, we have been mounting this thing on vehicles, on vehicle mounted setups, on directly to a vehicle or ATV, and there's motivation behind this, right? So safety is a big thing for us. I've been focusing a lot in the construction industry, and in the construction industry, there's a lot of moving parts. There's a lot of people walking around. There's a lot of dangerous vehicles moving around. So we want to make sure that we want to be able to integrate something so that we can fully control it remotely and acquire data pretty much any time. And some of the key factors to really make this work is that you got to have really both parts. You got to have the robot that operate and control remotely. More importantly, you got to have a scanner that you can have all the functionalities such as onboard registration. We want people to collect the data, register it automatically, and then send it off to a network for data, to transfer data onto a network, whether it's a NAS drive or a Amazon cloud, so that other people can access it remotely. And then fully integrated GPS and IMU. So we got to have these sophisticated sensors on the scanner in order to really make this integration work. We couldn't just put any scanner on here. I guess we could, but we wouldn't have the capability to really use it to its full potential without the sophistication of the VZ I-Series scanners. And then, of course, one of the coolest thing I thought on here was the programmable apps through Python, right? So with the apps, we can tell the scanner, without controlling it, we can say, hey, scan at this time during this day at this very hour and this very second and this very many times at this type of resolution. And then register the data together and then send it off to a NAS drive or an Amazon cloud. Just some quick attributes on the robot that we're working with. It's called Spot, which is a robot engineered by Boston Dynamics. If you don't know Boston Dynamics, they make very sophisticated robots, whether it's four-legged or two-legged. Check out the website. You'll see a lot of cool stuff about them. But this thing works. I'm going to show you some results in a little bit, but here are some attributes on the robot. One of the key things that we like this robot, it's got a very heavy payload. Programmable API, navigating challenges, terrain. Average runtime, of course, is 90 minutes without any payload, but with a payload, that time does run down. All the testing I've done, I've used this robot about half a dozen times, and I've never ran any kind of issue where, on a construction project, which I'll show you next, that I did not get a chance to finish scanning. Yeah. So, and that's because the scanner is so fast. You can imagine with just less than 1 minute scan, how many scan positions you can accomplish within 30 minutes or even 45 minutes. Of course, you won't get 90 minutes of runtime on the robot with this type of payload. So here you can see I have this robot program. Sorry if it's too loud. I have this robot program so that it's fully autonomous using the RFQ code that's pasted on the column right there, right in front of you. You can see once it hits that marker, it recognizes that marker, then it knows to turn directions. And of course, this thing has collision avoidance, so we're not going to worry about tripping over objects and stuff like that. But yeah, the moving autonomously throughout an active construction site. And of course, we were just there to watch it, but we made sure everybody was just being normal, walking around, doing their job. And then we were able to, again, program the robot to walk around on a site on a routine basis. And then, of course, the data is collected automatically. Let's show you some more. So here, this video shows the scanner and the robot can work together and collect highly accurate data and register it all together automatically. You can see here, this is just an outside scan of a building, active construction site. And then the data is registered together. And then from that, the data is sent to a cloud. And then from the cloud, we can then either create, just as simple as this, a drainage map where, we can create contour lines, elevation. This was collected before the exterior parking lot was graded for pavement pour or to create a parking lot. You see the retention area. Here I have a scale where red is high and blue is low, and the difference between that is 3 centimeters or 30 centimeters difference between the red and the blue. And then this is collected from that data set. Okay, so that concludes the portion for me. Again, here is my contact information. I'll leave it up here for a short period of time. And then my colleague Thomas Gaisecker is going to present next. So if you have any questions, feel free to reach out to us directly with any question.
Now, let's speak about the brand new lists Geotech plugin for Rsync Pro and RiMining. It really delivers fantastic results for geological and geotechnical applications. This was a request from our customers for many, many years, and now we can offer this solution. The plugin calculates local dip angle and dip direction, and this data is used for rock face orientation analysis and visualization of the results on a so-called pole plot. The graphical user interface within Rsync Pro enables to set the number of expected classes and also the parameters for the class separation. On this example, as visualized by the pole plot, 3 dominant orientations classes are detected. This classification is stored as a new attribute within the RIEGL database and can be used for the view type setting, as you see here. And if we have a look on the detail view, one can clearly distinguish between the 3 dominant rock face orientations shown in green, yellow, and red. And this plugin really helps specialists to identify important geotechnical characteristics of rock faces. Another new mining-related feature of Rsync Pro and RiMining is the Voxel Comparison tool, which enables fast and efficient 3D data comparison. For further details, please have also a look on our published RIEGL YouTube video. You can also scan this QR code to watch the video. I just want to quickly highlight how easy to use this tool is. First, you extract a voxel dataset from a scan or a point cloud as a reference dataset by just clicking on that object and using the option Extract Voxels. Data within each voxel is represented by a plane and the standard deviation representing the noise of the data in respect to the extracted plane. The normal vector defines the orientation of the plane. And finally, you select another dataset or a number of datasets, which can be again scans, point clouds, or even voxel datasets, to be compared against the reference voxel dataset by using the option Compare with Voxels. These datasets get now a new attribute called Distance to Surface, which is representing the distance along the normal vector. And within the view type, you can now select this attribute and view your data according to the distance to the reference dataset. We have here 2 examples. First example shows a slope, which was scanned every 2 minutes from a distance of around 100 meters. By switching through the scans, one can see immediately that we can even detect millimeters of movements. So we see the movement long before something happens. And this gives us a lead time of approximately 45 minutes in this example before the real failure happened. And this gives time to remove people, employees, operators, and machines from the endangered areas. Second example here, we have scanned a big ice cave, which was scanned twice between 2 years. On the left side, you see an image. On the right side, you see the scan data visualized by reflectance and the ice areas highlighted in blue. And now we see the result from the Voxel Comparison tool, and we can visualize with this new tool immediately zones of ice growing, indicated in blue, and ice decreasing, indicated in yellow to red colors. As already mentioned, the comparison runs along the normal vector of the estimated plane within each voxel of the reference dataset. Therefore, It is a real 3D comparison, and it works also on vertical and even overhanging areas where standard tools using 2.5D algorithms cannot deliver correct results. Now, let us speak about future trends in mining. Everything goes digital and virtual, and the same is in mining. I show here a standard computer network within a mine. Computers are connected via a DHCP server or router, and outside connection is realized via internet and the safe VPN connections or other similar safe connections. This is a standard computer network. On the next slide, here I call this a smart mine network configuration. Instead of a standard router, we have Wi-Fi hotspots, and even machineries and equipment is part of this network. This I call a smart mine network configuration. Also, our RIEGL VZI series scanners can be easily integrated in such a network by using our standard interfaces, TCP/IP LAN interface, the wireless LAN interface, or even the LTE module. The scanner itself is a simple Linux computer with an IP address, therefore really easy to integrate into the network. Once the scanner is integrated, it can be remotely operated from anywhere inside that network and even from outside with the VPN connection, which means you have worldwide remote access to your scanner. Our new Rsync app is running on the scanner, and it enables data synchronization to a file server, which is another computer inside that network. The data synchronization itself runs in the background and is fully independent from the data acquisition. Within the graphical user interface of the app, the user defines the file server location by a host name or IP address, and you also define the synchronization interval. And again, it is fully independent from your data acquisition. Big advantage is that it delivers you directly a backup of your scan data on that file server, and your scan data is even available if the scanner is shut off. It is stored on the file server. The new mining apps which I introduce on the following slides should be seen within such a network environment. The monitoring app does automatic change detection by calculating differences in respect to a given reference scan. The app allows flexible data acquisition scheduling, as you see here, fixed interval schedule or manual, and it allows also the settings of change detection thresholds. For every scan, a 2D image is calculated, and for every pixel of this image, a robust neighborhood analysis delivers a local surface normal vector. Differences are calculated along this normal vector, so we are not using simply line of sight, we're using the real normal vector of the local area. A web server is also available directly within this app. So that means the results can be viewed by using a simple web browser within this network, and you see immediately the results of the monitoring app. The name of the second brand new mining app is Design Compare app. Instead of using a reference scan, a design model of the pit can be loaded on the scanner. The scan data is now compared with the design model, and undercut and overcut is visualized on the 2D image within the web browser. Overcut is visualized here in yellow to red, and undercut is in the blue colors. This is really helpful because undercut is a loss of money, while overcut is even more critical because it is really a safety relevant issue. And remember, if you are the controller of this digging machine and you have a laptop on board connected with the network, and you just have a web browser on your laptop, you see in real time the results of your digging. Last but not least, we offer the slope angle app to visualize the actual slope angles of our scan data. For example, again, the operator of such a loader can see in real time the data. And for example, this operator dumps material on a big stockpile or dump area. And within the app, we can define a critical threshold value. In this example, 70 degrees. Everything above is highlighted in pink. So the operator of the loader sees immediately what kind of slope angles he creates by dumping the material. I know this was much of information within such a short presentation. I hope I could transport all the relevant information for you, and thanks a lot for joining us today.
Thank you, Thomas, for the excellent update on our mining news and apps and network. I really like all the flexibility that the VZ I-Series scanner have on developing these tools to use in real-world application. So, yeah, now we can open up to some questions. We'll take them accordingly to what the questions are. So, yeah, feel free to ask any questions, and if we don't know the answers, then we will send me an email, and then we'll answer them at a later date. So, I see that there's two questions. I replied back to them, but I'll answer them now. What settings does the task 4 use when using GPS? So in my slide, let me see, that I had up, if you want to make use of the survey control, break the tasks into 2 parts. And then in MSA2, that's where you can define if you're using survey control, and if you want to put a higher emphasis on it by putting in survey control values or checkpoints, or utilizing just the scan. So in that case, earlier, I said that MSA2 accounts for 6 degrees of freedom, and one of them is to make use of the GNSS. So it does make use of the GNSS if you don't define specifically if you want to tie it down to control or not. So, yep. We had another questions that said, how much is the overlap between LiDAR scans and overlap on photographs in percentage? This depends. So this depends on the areas that you're scanning. So if you're scanning inside of a building where you have closed wall objects and walls that are close to your scanner, then you only want to move the distance of the object, right? So you can't really move far inside of a building. But on outside of the project that I showed you, I was moving approximately, I was on a lift system, so I moved it anywhere from 150 feet to 200 feet. But measuring percentage-wise, I like to keep it within 40% of overlap. Right? So that's really hard to quantify too as well. So it all depends on the project's scene. And then for images, I use 35%, which takes about 7 images for each scan positions. All right, well, that concludes our presentation. Thank you, everybody, for participating. Hopefully this information is useful for existing RIEGL users. And if you're not, if you want to find out more information, please contact us and we'll share it with you. Thomas, thank you very much for your time. And we will talk at another time. All right, everybody, please stay tuned for our next webinar. We will be making many announcements on social media, so please connect with us and also visit our website for more information.